Hello and welcome to the sixth of 8 videos for Chapter 3 for Basic Sentential Logic, Informal Fallacies, and Cognitive Biases. On this video I'm going to be discussing conditional proof. So what we've done in the first 5 videos is talk about the proof method in general. We've had introduction to the 6 inference rules that we'll be using. And then also a video that describes some common mistakes that people make. What we're going to be doing now is talking about conditional proof, which is the first of 2, we can call them proof strategies. The second one is indirect proof, and we'll be talking about that in Chapter 4. Now, in order to get our head around conditional proof, I'm going to start with something that initially has nothing to do with proofs at all, which is this example, which is the lethality of a liquid. So for liquids that someone might drink, if you call a liquid lethal, what does that mean? Its meaning is a conditional, right? It means something like if someone drinks it, then that person will be killed, something like that. So in order for a liquid to be lethal, this conditional has to be true of that liquid. Okay, the meaning of something being lethal is this conditional. Now, notice, and this is why it's a conditional, both the antecedent and the conclusion might be false, right? So maybe nobody has ever drunk that liquid, right? So the antecedent could be false. Right? If somebody drinks it, they'll die. Well, maybe nobody has ever drunk this liquid. And maybe nobody's been killed by that liquid. So the consequent is false, right? It doesn't matter. The conditional could still be true. You could still have a liquid that's lethal, even though nobody's ever drunk it and nobody's ever died from it. Okay? That's a clue that it means the meaning of lethal is this conditional. Okay? Now, suppose you discover a new liquid. You're in your chemistry class and you're doing some stuff, and some new liquid that's never been synthesized before you manage to synthesize it. And you're wondering, hey, is this liquid lethal or not? How would you determine it? How could you tell if it was lethal? Well, what you want to know essentially is if this conditional is true. If D, then K. If someone drinks it, then they'll be killed, right? You want to know, is that conditional true? How can you tell if the conditional is true, right? Well, here's one way. You make the antecedent true and see if the conclusion becomes true as a result of that. Okay? That is, or here's an example, you could get a friend of yours to drink the liquid, which would be a way of making the antecedent true, and then see if they die. Right? See if the consequent becomes true, right? So you get them to drink the liquid and you see what happens. If they die, then you know the liquid is lethal. Now, the upside of that process is that you can verify that the conditional is true, right? You can verify that the liquid is lethal. The downside, of course, is that you had to kill your friend in order to learn that piece of information. Now, ideally, what you'd like to be able to do is to kind of have it both ways, right? You'd say, well, maybe you have your friend drink the liquid, but in a way that doesn't really count, right? Like, so, as long as we're in fantasy land here, right? You make your friend drink the liquid, you see if they die, and if they do, you go back in time and you stop yourself from giving your friend the liquid, right? Because you learned what you wanted to learn, but you don't really want to kill your friend. Okay. Now, in real life, you can't do that. But here's the great thing. You can do it in a proof, and that's what conditional proof is. Okay. With conditional proof is when you're in a situation, in a regular proof, right? And you, for some reason, you think to yourself, gosh, I really want to know if a certain conditional is true. I want to be able to derive a conditional. Call it if alpha, then beta. Okay. And what you do is you make the antecedent alpha true, and you see if the consequent is also true. given that you made alpha true, okay? But you don't really make the antecedent true. You just pretend to make it true to see if beta would follow, okay? Once you verify that the conditional is true, right? You pretended that alpha was true and you saw if beta would become true as a result. You sort of unmake the antecedent true. You sort of acknowledge that that whole part of your proof was just kind of make-believe. Okay. Now in a little bit more detail, the basic idea is that you want to prove that the conditional, if alpha then beta, you want to prove that that conditional is true. And you do it by assuming the antecedent. You assume alpha. You pretend that it's true, so to speak. And then you see if B becomes true as a result. You see if you can derive beta from your assumption of alpha. Now to walk through the process. At some point, you want to be able to derive the conditional. Now, maybe sometimes you can derive this conditional with conventional means, right? You've got rules of inference. You might be able to get the conditional just that way, right? But suppose you can't figure out how to do it. What you do is you start a subproof. And the subproof means this is the part of the proof that is really just kind of pretend. It doesn't really count. And you add an assumption consisting of alpha, the antecedent. Okay? And then you proceed using the rules. Now your goal is to derive beta. You want to see if you can get beta once you've pretended that alpha is true. Okay? Now suppose you do that. At that point, we don't know whether alpha really is true. You just kind of pretended it was. Okay? And we don't know if beta is really true, right? We managed to derive it, but only in the pretend condition that alpha was true. But what we have shown is that if alpha were true, beta would be true. But that fact that you showed in that part of the subproof just is what the conditional if alpha then beta means. So the subproof shows that that conditional can be validly inferred. Okay, this will make a lot more sense when we walk through some examples. So suppose you have this proof. The conclusion is a conditional, and so that means I want the conditional if G then K. That's something that would be really cool if I had. But I can't figure out how to do it, and in fact, with the rules that we have currently, you can't do it right now. Once we get the replacement rules from Chapter 4, we'll be able to. But with what we have so far, it's not possible. But it is possible with conditional proof. So step 1, as always, with conditional proof, is to get clear on the conditional you want. Okay? Now in this case, the conditional I want is if G then K. Why do I want it? Well, in this case, the reason I want it is because if I get it, the proof's over, right? Because that's also the conclusion of the proof, right? So that's why I want this. Now that's not always going to be why you want a conditional. Sometimes the conditional might just be something that you need in order to finish your proof somehow, and we'll see examples. But step 1, get clear on what I want, and I want this conditional. Step 2 is I'm going to assume the antecedent of that conditional. So if this is the conditional I want, if G then K, the thing I'm going to pretend is true is the antecedent, G. Okay? So once, this is just like the lethal liquid. If the conditional you want to, you want to know if the liquid is lethal, that means the conditional you want to establish is if someone drinks it, then they will be killed. That conditional then tells you the thing that you need to make true, the antecedent. You make someone drink it. Okay, and then you see if the consequent follows. So this is the antecedent. I'm going to pretend this is true. So this is going to be my assumption. And so I'm going to make this assumption in the proof. Now, we're starting what we call a subproof. So this is the part of the proof that's really just kind of pretend. And I'm going to indicate that by indenting the line, drawing a little arrow that points at my assumption, and my justification is going to be ACP, assumption for conditional proof. Okay? Now, once I've done that, I've figured out, I know what conditional I want, I've assumed the antecedent. My goal is to see if I can derive the consequent. Okay, well, what's the consequent? Well, the conditional I want is if G then K, so I'm seeing if K, see if I can derive K. All right, so you just go back to using all of the rules and everything as normal. But now my goal is to derive K. And you can see that that's pretty easy to do. Okay, I have a conditional, if G then T, I have the antecedent G, so I can get T by modus ponens on 3 and 1. I have T, so I can get T or S by DI. That's the antecedent of this conditional, T or S. So now I can do modus ponens on 5 and 2 to get K. Great. Mission accomplished, right? Once I started my subproof, my goal was to derive K. Assume G and derive K. And I've derived K. Okay, so now what I want to do is end the subproof. This is the part where, okay, yeah, you saw your friend die, so you know that happens, and now you're going to go back and just make that whole thing pretend. You didn't really give them a liquid, they didn't really die. This is ending the subproof. So what I'm going to do is I'm going to draw a line from the bottom of this that goes up to this arrow, and it's just a way of graphically representing that this part of the proof, this subproof, is now closed. I'm done with that part. Okay? And this is where you're sort of acknowledging that that whole segment was just pretend. Okay, that's subproof. Now the next line, once you've closed that subproof off, the next line has to be, right, there's a very specific thing you have to write. It has to be a conditional whose antecedent is your ACP, your first line, and whose consequent is the last line. Now I stated that as though it's a requirement, but that's basically what you wanted. You set the whole subproof up that way because that's exactly what you wanted on that line, is the conditional if G then K. And my justification is the entire subproof, lines 3 through 6, conditional proof. Okay, let's see another example. Step 1, get clear on the conditional you want to derive. Well, the conclusion is a conditional, and it's not obvious to me from this how I could derive if X then Y using the rules of inference that we have, so I'm going to try conditional proof. Since this is the conditional I want, if X then Y, that tells me what my ACP is going to be, and it also tells me when I should end the subproof. I'm going to assume X, and I'm going to end the subproof when I derive Y. So assume X, I'm going to indent with an arrow. Justification is ACP. And now my goal is just to derive Y. And you can see that's going to be pretty easy. I can do modus ponens on 3 and 1. This is the antecedent of that, so I can get not Z. I can do disjunctive syllogism on 2 and 4. This is the negation of the first disjunct, so I can derive the second disjunct. And now I'm done. I've derived Y. That was my goal, remember? So now I'm going to close this subproof off. And then the next line has to be a conditional whose antecedent is the ACP, antecedent is X. Whose consequent is the last line, Y. And the justification is the entire subproof. Lines 3 through 5, conditional proof. Okay. What about this one? Now notice the conclusion isn't a conditional. Okay. Now does that mean you can't use conditional proof? No, you can use conditional proof because maybe even though the conclusion isn't a conditional, maybe there's some conditional such that if I had it, that would help me finish the proof somehow. Okay, and it turns out that's right. I'm looking at up here at my premises. I'm trying to derive M, I'm looking at this and I'm saying, hey, here's M. It's the consequent of this conditional. If I had this, if I had the antecedent, if K then L, then I could just use modus ponens to get M and I'd be done. Okay? So now I've recognized that there's a conditional that would be helpful for me to have if K then L. So I'm going to use conditional proof. And there's no way I could get that conditional without conditional proof, given the rules we have in Chapter 3 so far. But conditional proof will work. I'm going to assume K, and now my goal is to derive L, and that'll give me this conditional. So I'm assuming K, and you can see it's going to be super easy to get L, right? I have K, so I can get S or L by modus ponens. I have the negation of that, so I'll be able to get L by disjunctive syllogism. Okay, so K, my assumption for conditional proof, I've indented. Then I can do modus ponens on 4 and 2. That is the antecedent, so I can derive the consequent, S or L. Now, this is a disjunction. I have the negation of the first disjunct, so I can derive the second, L, which is what I wanted. Okay, my goal was to get if K then L, so I assumed K. My goal was to derive L, which I've done now. So now I can close this subproof off, and I've got if K then L. ACP, antecedent, last line, consequent. Justification is 4 through 6 conditional proof. Now obviously the proof isn't over because if K then L is not the conclusion, right? If K then L is just something that I realized would help me get the conclusion. So now I can use this on with line 1 and modus ponens to get M. Line 717 modus ponens. Okay. Now, there's a clarification I want to make right now. So let's go back. This is the same proof, and this is the point where I made this K as the assumption. A lot of times, students will come in and they'll look at the solution to a proof that use conditional proof or something, and they'll point to the ACP and they'll say something like, where did K come from? Okay. And the reason they're asking that question is because they're looking for somewhere in the proof that K is. Like, well, that's not here in the conclusion, and right, where did you get K? So the answer, though, is never that it came from some location in the proof, right? Like from some part of the conclusion or something. That's never the answer to that question. What is the answer? The answer is it came from my plan. Okay, my plan, remember, with this proof was, hey, if I can get this antecedent, then I can use that with modus ponens to get M. And so my plan was, gosh, I really need if K then L. My plan, the thing, I devised a need for the conditional if K then L. That's where K came from. Whenever my decision that I wanted the conditional if K then L, whatever that conditional was, its antecedent is the ACP. So that's where K came from. It was the antecedent of a conditional that I wanted. Now, why did I want it? Who knows? There could be 1,000 reasons that I want some particular conditional. Maybe it's the conclusion, or maybe it's like something I realized could help me get the conclusion. It doesn't even have to be helpful at all. I could do a conditional proof in the middle of proof that doesn't, such that the conditional I derive isn't useful for anything, and then I just continue and I do the proof a different way. And the conditional proof was just there wasting space. But that's fine. If you asked, where did my ACP come from, the answer would be, well, it came from the fact that it was the antecedent of the conditional I decided I wanted. Even if the conditional I decided I wanted wasn't for any purpose, right? So the answer is always that came from your plan. Okay? All right. Now that we've introduced conditional proof and seen some examples, I want to go through some rules just to kind of tighten the bolts up here a little bit. The first thing you do, once you've decided you know there's a conditional you want, you've got that down, is you start your subproof by indenting, and you draw the little arrow, and you designate the first line as your assumption for conditional proof. And remember, what is your assumption for conditional proof going to be? It's going to be the antecedent of the conditional that you want. Okay. Second rule. The conditional proof ends anytime you want it to end. Now, what do I mean by this? Well, you'll see in chapter 4 when we get to indirect proof. That's the second of the two proof strategies. It also starts with the subproof where you make an assumption, but there's a very specific thing you need to derive before you can end an indirect proof. And if you try to end it any other time, other than when you've derived a certain very specific thing, then you've done indirect proof incorrectly. With conditional proof, though, you can end it any time you want. Once you start it, you can just decide to end it any time, and that's fine. It won't be incorrect. So here's an example of what I mean. This is the proof we did just a minute ago. I assume K, derive L, get if K then L, and then get M by modus ponens. Okay. Now, in this case, what I did is I assumed K, and I ended my conditional proof once I got to L. But I could have also done it this way. I could have assumed K, got S or L by modus ponens, and I could have ended it right there. Would have been fine. Had I done that, then the conditional I would derive would have been obviously K antecedent, last line is the consequent. Okay? Now, here's the thing I want to say. This isn't wrong in terms of using conditional proof correctly. If I did this, I wouldn't get any points off on a quiz. Okay? I can end it any time I want. I could end it at line 5 if I want. Why didn't I do that? Well, the reason I didn't end it on line 5 isn't because that would have been a mistake. The reason I didn't end it on line 5 is because if I ended it on line 5, I would have gotten a statement that wouldn't help me. If K then S or L doesn't help me at all move my proof forward. In fact, this statement is already here on line 2, so it's like completely pointless. Okay? The reason that I ended it with L, that I decided to wait until here, is because if I ended it on line 6, I get something that was helpful. Okay? So that's when you end it. You can end it anytime you want. It won't be wrong, but it's advisable to end it when you've managed to derive the consequent of the conditional that you want, right? Remember your plan. Your plan was you wanted a certain conditional that tells you what your ACP should be, and it also tells you when you should end the subproof. Okay, so let's go back to the rules. That was rule 2. Rule 3, once you've done that, once you've decided you want to end your conditional proof subproof, you mark it off. Sometimes that's called discharging the assumption, and that closes your subproof. This is like you indicating that that whole part of the proof was just pretend. Okay? Once you've done that, the next line after you've closed that subproof can only be one thing. It has to be a conditional whose antecedent is your ACP and whose consequent is the last line. Okay? And again, this sounds like, oh, it's this really strict rule you have to follow, which it is, but it's actually good, right? It's because of this rule is why you picked the ACP you did and why you ended the subproof when you ended it. It's because that's exactly the conditional you wanted. Okay. Rule 5. All subproofs have to be closed before your proof can end. So what does this mean? Here's a proof. Don't think we've seen this one yet. Doesn't matter. Here's the premises. I assumed R. I got D and A by modus ponens. I simplified A. And then at this point I go, oh, look, I'm trying to derive A or B. I've got A, so maybe I can just go A or B, DI, and I'm done. I'm done with my proof now because I managed to derive the conclusion of the proof. No. Why? because before I can end the proof, I have to close all of the subproofs. And this here is a subproof I started, but I haven't closed it yet. So that's wrong. If you do this, points off, big time points off. That was rule 5. Rule 6, once a subproof has been closed, you can no longer cite any lines in it. Okay, so for example, in this subproof, trying to get A or B, I assume this, assume R, derive A, get if R then A. And then at this point, I look, let's say, I look back up here, I say, oh, I'm trying to get A or B. Oh, I know how I can get A. I can do simplification on line 5. So here on line 8, I'm trying to use a rule, simplification, on a line that's in a subproof that's been closed. You cannot do that. Okay, because once you've closed it, that's you acknowledging that this is all pretend. This didn't really happen. Right? This is like when you went back in time and you didn't really kill your friend. Right? All of this stuff didn't really happen in the proof. It was just pretend. So you can't actually cite this. Okay, so this would be wrong. Okay, this is me trying to cite a line that's already been, that's in a closed subproof. Can't do that. Okay. Those are the rules for conditional proof, and that's the introduction to conditional proof. There's one more video for the material, and then another one where I'll be working through the practice quiz for Chapter 3. And then that'll be it.